Good day. Today's lesson, we are going to do linear programming. Linear programming is a mathematical method used to find the best possible outcome when resources are limited. The goal is either to maximize profit or production or minimize cost or time. Those are the two goals for linear programming. And then we have the general form of a linear programming model. So for two decision variables, which is x and y, the objective function may be written as a maximize or minimize, which is equals to ax plus by. So remember, x and y are your decision variables. So decision variables are unknown quantities that must be determined. You will see from your study guide. And then we have our objective function. Objective function is a linear function that represents the quantity to be maximized or minimized. So this one, so decision variable, this is quantities. Quantities that must be determined. And then we have our objective function. Objective function, we say that is a function that represents, so this is the function that represents the quantity to be maximized or minimized, to be maximized or minimized. So these definitions, you will find them from your study guide. Okay. And then the object function is subject to linear constraints such as, so these are our linear constraints. We have A and B are your variables, as you all know, and then you'll see as we go on with the examples. So we have a less than, sometimes it can be greater than or equals to. And then these two, your x greater than 0 and your y greater than 0, these are what we call negative constraints. So this negative constraints, the condition states that decision variables cannot be negative. So this is the condition for these two. So it tells us that the decision variable cannot be negative. So meaning this can't be negative. All right. And then the inequality sign depends on the wording of the problem, sorry. So on linear programming, so we'll be dealing a lot with the word problems. So the inequality, so this sign, your less than or equals to, greater than or equals to, an equal sign. These signs, they will depend on the wording of the problem. So when we have a less or equals to, you will see with the word at most, no more than, maximum available, and cannot exceed. Usually these, they lead to your less or equals to. At least, minimum required, and not less than, usually lead to greater than or equals to. All right. And then exactly leads to the equal sign. So with my other students, I told them that this less than or equals to is your left-hand side. So this sign, actually, you can do it with your left-hand side. If you can, I can make the sign with my left-hand side, it's a less than. Your right-hand side, it's greater than, in case you don't know the difference. All right. And then we have the following example. All right, so before I move on, these two constraints, I don't know if I explained, these two can be represented by labor hours, raw material, money, or dietary needs. It depends on the problem that we are given. So example. So we have an example here. It says that a furniture manufacturing company produces tables and chairs tables, and chairs. And if you can remember, I said that decision variables are quantities that must be determined, okay? So we have our tables and chairs. With your first statement, that's where you're going to find your decision variables. So this, I'm going to call it my X, because we are dealing with tables and chairs. Then this one, I'm going to call it Y. All right. So you cannot answer questions if you don't know how to analyze the statement. And then the following, it says that each table gives a profit of 50 rand. So a table gives me a profit of 50 rand, while each chair gives a profit of 30 rand. Okay. And then they're saying that to produce one table, the company requires 3 hours of labor. Oh, okay. And 2 units of wood. So we have labor, we have wood. And then they're saying that to produce one chair. So to produce a table, one table, you are going to need what? 3 hours of labor and then 2 units of wood. And then to produce one chair, so for the chair, we are going to need 1 hour of labor and then 2 units of wood. And then they're saying that the company has 120 hours of labor and 100 units of wood available each week. All right, so normally when I do these problems, I use a table method, so you will see as we move on. So let's go to the first question. The first question says, define the decision variable for this problem. So as I said, I already found my decision variable. I know that X is, so I know that my X is the number of tables. And then I know that my Y is the number of chairs. So I already found the answer for my A from the first line of my statement, problem statement. All right. And then now, okay, I don't know if this is visible. Okay. And then now we move on to B. So B says, write down the objective function and inequality constraints, including the non-negativity. So we all know the non-negative constraints, all right? So for me to write my objective function inequality constraints, I use a table method because I find it easy to use a table method. So you can also try it. So now we are going to start with the table. Oh, looking for my ruler. Okay. So we are going to do the table. So because I already know my X and Y, so what I'm going to do is, okay, I'm going to draw my table. Okay, let me use black. I'm going to draw my table. Okay, so, okay, this is my table. Okay. So I use the table. So I'm going to start with my X and my Y. So we said that my X is the number of tables. So, okay. So I am going to start with the number of tables. So I'm going to say this is my number of tables. So I'm going to say tables here, tables, and then I say X, and then I say chairs. I find the table method easy. And then I say Y. All right. And then I have two things. I have labor, and then I also have wood. Both my chairs and my table, they both have labor and they both have wood. So I am going to say this side, I'm going to call this labor. First, let's start with labor. So the labor for tables, let's see. Tables gives a profit, okay. Let's go to labor, okay. To produce one table, the company requires 3 hours of labor and 2 units of wood. 3 hours of labor, so this is 3 hours of labor, and then 2 units of wood. Okay, so it means this will be wood. Wood. All right. And then now we go to chairs. So with the chairs, they say that to produce one chair, it requires 1 hour of labor and 2 units of wood. 1 hour of labor, 1 hour of labor, 1 hour of labor, 2 units of wood. All right. And then now we have the price. So if you can check here, we have the price for table and the price of chairs. So where does this? So this is here. So I'm going to write the price here. So the price. So the price for the table, one table, 50 rand. So I'm going to write the 50 here for the table. 50. And then for the chair, it's 30. Okay, so let's see what's missing. And then what's left is they're saying that the company has 120 hours of labor. The total of labor is 120. So I'm going to write the 120 here. 120 hours of labor. And then let's see about the units. Units is 100 units of wood. So this is 100. So this is how I do the table. So if you don't understand, you can rewind the video and then watch it again. Right. So now I have everything that I need. Now I'm going to start answering. The first question, they're looking for objective function. So objective function. So I'm just going to write it here first. Okay. I'm going to start with the objective function. Objective function. My objective function, I have, which is, we said that the objective function, we said that the objective function is the function that represents the quantity to be maximized or minimized. Okay, so it's the ax plus bx. So that is going to be profit is equals to, so we are maximizing profit here. So this will be profit, because it's money, it's equals to, for the x, the price, it's 50. So it's going to be 50x plus 30y. And then after this, now we move on to inequality constraints. So because here they did not mention at most, at least, maximum, minimum, so it means that we cannot have more chairs to, you can't have, when we write the inequality constraints, right? It's going to be 3x plus 1x is less than. You cannot have more of these to produce, to have 120. So what's going to happen is that it's going to be 3x plus, so it's less than. If they don't mention anything, it's less than. All right, we can't have more. I hope I make sense, but we'll see as we move on. So we are going to have inequality. Because they did not mention anything, I'm just going to say less than. Inequality constraints. Inequality constraints. We are going to have the first one is this one, the labor. All right, then we're going to have wood. So it's going to be 3x plus 1y is less or equals to 120. And then the other one is 2x plus 2x plus 2y is less or equals to 100. Let's not forget the non-negative. The non-negative is always, we can't have a negative, right? So it's always x is greater or equals to 0 and y is greater or equals to 0. These are what you call your non-negative constraints. I hope this makes sense. So these are the answers that they wanted. I always start with the table because I find it easy. All right. And then now we move on to C. So C, they're saying that, no, I want to check the space. I'm checking the space. They're saying that graph the inequality or plot the inequality constraints and shade the feasible region. All right. So we are going to start with finding our point. You cannot draw a graph without the point. So when we draw the graph, we are going to use what we call the intercept method. All right. So we are going to use what we call the intercept method. When we draw the graph, we use what we call the intercept method. If you did maths, this is grade 9 maths, right? We used to draw the graph with the intercept method. If you don't remember, I am going to remind you. Intercept method to find the point so that we can draw the graph. So the intercept method, we are going to use our formulas, right? Our functions. So we have these two functions. We have this 3x plus y, 1y less or equals. So we are going to use the equal sign when we use these two functions. All right, so let's start with the first one. We are going to start with 3x plus y. So we are going to start with this one. 3x plus 1 times y is y. So I'm just going to write y. 1y, y is the same thing. All right. So I'm just going to use the equal sign, not the less or equals to, so that I can be able to solve. So I'm going to start with this one. All right. So with this one, when we solve for the intercepts, we are going to start first. We're going to say you're going to put, let me use a black pen, sorry. I feel like this is red. I'm going to need this red. Sorry. Okay, so it's 3x plus y is equals to 120. So the first thing we do, we are going to put x is equals to. So we start with this one first. And then after this, we are going to move to the other one. So with this one, you are going to firstly start by putting, we're going to put the intercept. This is how it works. You put x is equals to 0 first, way into this equation. Right. So when you put x is equals to 0, it means that I am going to have 3. Then wherever I see x, I put 0. And then plus y, then it's equals to 120. So wherever I see x, I'm going to put 0. And then 3 times 0, it's 0. Then plus y is equals to 120. And then we all know that 0 is just 0. So this will be y is equals to 120. Even if you say 120 minus 0, it's still 120. All right. So it means that now I have my point, my corner, my point, sorry, to plot the graph. So when you have the point, your point must always be x, y, because we're going to use x and y. We're going to use x and y on our graph. When we draw the graph, our independent, dependent are going to be x and y, because remember, we spoke about this when we started. We said that our decision variable x and y. So we're going to be talking about x and y now. All right. So my point must be in the form of x and y like this. So you always start with x. It's x, then y. So it means that here, when I was solving, I said that my x is 0. I said that my x is 0. And then my y is, the answer I got is 120. So when my x is 0, when I input x is equals to 0 into a function, into this function, my y will always be 120. Input, output, if you remember. Right, when coming to functions. So now I'm done with putting my x is equals to 0. So now I'm going to put my y is equals to 0. Same thing. Now you put y is equals to 0. So y is equals to 0. It means that wherever I see y now, I'm going to put 0. So this will be 3x plus a bracket. Then I put 0 where I see y. And this is equals to 120. Then 3x, then plus 0. I mean, 0 is just 0, if you remember what I said. And then this will be 3x is equals to, well, actually I can just jump this because I need the space. I mean, 0 is just 0. 3x and 0, I mean, I'll be left with 3x here. And this is equals to 120. Now I need to solve for x. So I am going to divide both sides by 3 because I need to solve for x. And then my x will be equals to, so 120 divided by 3, we are going to get a 40. So the answer is 40. So therefore it means that my point xy will be, my x is 40, then my y will be 0. So every time my x is 40, y, the output will be 0. That's my second point. So I got my 2 points from this function. So I'm going to do the same thing for this function. Remember, instead of less or equals to, I'm just going to use the equals to, because these two, all right, if I'm solving for x, I need to use one of them. All right, so it's going to be 2x plus 2y. So I'm going to use 2x plus 2y. So 2x plus 2y is equals to 100. So I'm going to use this one. And then I'm going to put x equals to 0, then solve, then put y is equals to 0, then solve. Sorry. All right, so I'm going to do the same thing. So this will be, we're going to put x is equals to 0. So wherever we see x, we put 0. So this will be 2, then x. Okay, I'm going to put a bracket, then plus 2y. So wherever I see x, I put 0. So this will be 0. And then now we solve 2 times 0, it's 0. Then plus 2y is equals to 100. And then now this will just be 2y is equals to 100. Then now I need to divide both sides by 2 because I am solving for y. Remember this, they cancel. I hope you know that these two, they cancel. Or if you divide 2 by 2, it's 1, okay? So this will be y is equals to 50. So it means that the point here is going to be, it's going to be x, y will be my x, when my x is 0, I didn't even put that, x is 0, then my y will be 50, the output will be 50. So this is the point, okay? I'm writing them as this because I'm going to need them when I do the corner points. Okay, so now we move on to putting, we put y is equals to 0. Same procedure. Okay, so y is equals to 0. Then I'm going to have 2x plus 2, then bracket, I'm going to put 0 there, then it's equals to 100. So wherever I see y now, I put 0. 2 times 0 is 0. So this will just be 2x plus 0. 2x plus 0, then it's equals to 100. Then this is just 2x is equals to 100. Then we divide both sides by 2 because we are solving for x. So these two just cancel. Then my x is equals to 50. So what does it mean? So this means that now my point xy will be when x is 50, then my y is 0. 50, then my y is 0. So now I have my intercepts. I have my points now. I have all 4 of them. So now I can draw my graph. I sketch or I plot. So I'm going to graph the inequalities. All right. So when you graph the inequalities, okay, so I only have 2 variables, it's x and y now. And please do practice. I'm going to do another example. So I hope when I do the second example, everything will be clear. So this is y, this is x. Okay. Just gonna use as my scale. I see I have 40s, 100, 50. So I'm just gonna say 2, 4, 6, 8, 10 because I don't have a space. So I'm just gonna use that as my scale. All right. So it's this. I'm sorry. Okay. Okay. And then now, so this will be 20, 40, 60, 80, 100, 120. All right. And this is 2, 40, 60, 80, 100, 120. All right. And then now we are going to plot this one first. So we are going to plot these two first, these two, for this function. So for this function, we have 0 and 120. So my y is 120. So you can just go straight to y and put a dot there, and then go to x and then put a dot there. Then you draw the line. So you draw one function at the time. Please don't plot everything. Draw these two, put these 2 points first, and then you join the 2 points. You join the 120 and the 40. They say y is equals to 120. You go to y 120, then you put a dot. So that's what we're going to do. So I'm going to use a green color. So I'm going to put a dot here. Sorry. I'm going to put a dot here. And then x is 40. I'm going to put a dot here. And then you join the two lines. It was just a straight line. All right. And then after this, then you draw the second graph, okay? So I'm just going to use the red color. The second function, which is 2x plus 2y. All right. You'll see that our x is 50 and then our y is also 50. Then we join those two, all right? So because this is 40, so I'm just going to assume and say that my 50 is between 40 and 60. Same thing happens here, between 40 and 60. Then you join the 2 points with a straight line. All right. So this is our graph that shows the, what is it? It shows our constraints. It shows our inequality constraints. So now they want us to show the feasible region. All right. So the feasible region, it's this one. This is what we call the feasible region. Feasible region is where you have all your, where you can have all your graph, like two graphs included. So you'll see that I have a red line, I have a grid line. So this is what we call a feasible region. You can also see the definition of feasible region in your study guide. You will see it. So our feasible region always has 4 points, 1, 2, 3, 4. But you'll notice that we don't know the coordinates of this fourth one. So that's what we're going to answer on our second part. So we need to color. Okay. They say, okay, let's see. Let me try. Okay. So this is my feasible region. Okay. This is what you call a feasible region. Gosh. Okay, let me see if I can correct that. Oh gosh. Okay. Okay, just excuse my, let me try again. Okay, so this is the feasible region. I'm trying. Gosh. Okay. Okay, so this is the feasible region. Oh, it's not accurate, but it's fine. I tried. Okay, so this is what you call a feasible region. So this is our feasible region. Our feasible region. Okay. Feasible. Okay. Region. Okay. So this is our feasible region. All right. So we have all the points. If you can check, we have all the points. The feasible region is made by this, all the point. This point, which is what? Is 0 and 50. This one is 0 and 0. And then this one it's 40 and 0, but we don't know this one. So this point is what we call the point of intersection. So this point you see here, this one, where the two graphs they cross, we call it the point of intersection. That's the point of intersection. This point is what we call point of intersection. So with the point of intersection, when you have to look for these points here, you always solve these two simultaneously. Point of intersection. Right, but don't worry about that, I'll show you. So this is our feasible region. All right, feasible region, we have these two coordinates, this one, then we write them. This is 0 and 50. And then this is 0 and 0. And then this is 40 and 0. And then this one, we don't know it. We have to look for that one, but on our next question. All right, I hope I answered the questions here. Now let's move on. Now we go to number D. So number D says, find the corner point and determine how many tables and chairs should be produced to maximize the total profit. So the first thing we need to do, we have to look for the corner points. So again, I am going to use the table when I get here. I find the table helpful. All right. So before I use the table, I need to find this point, the point of intersection. So if you can notice, I have all the points, but I am missing this point. So these are what we call the corner points. All right, this 1, 2, 3, 4. The corner points are made. They are the ones that make the feasible region. So I need this point of intersection first before I can do anything. So let's look for the point of intersection. So that's the first thing we need to look for, point of intersection, and then the rest will follow. All right. So we are going to start with the point of intersection. Point of intersection, we solve it simultaneously. So I am going to say point of intersection. Point of intersection. Before I can even do the table of my corner points, okay. Point of intersection. Point of intersection, for us to find this point, we have to solve simultaneously. We solve simultaneously. So those who did pure maths will understand, but you also did this in grade 9. We solve simultaneously, solving for two variables at the same time. It solves simultaneously, all right? So we are going to use our functions, these two functions with the equal signs, not the less or equals, these two functions with the equal sign. So it's 3x plus y. So the first thing I'm going to do, I am going to take this. So we are going to use the 3x plus y is equals to a 120. So I'm going to transform this and make it y is equals to. So I'm going to take, I'm basically taking the 3x to my left-hand side. So I'm just transforming this equation to look like this. We'll understand why. All right. So this will be 120 minus. When you take the 3x to the left-hand side, it changes the sign and then it becomes a negative 3x. So I am going to call this equation 1. EQ1. EQ stands for equation 1. And then I'm going to write my second equation, which is 2x plus 2y is equals to 100. These two equations are the same. Please don't confuse this and this is the same thing. I just transformed this to this. I hope it makes sense. Don't know which color should I use for transformation. So I'm just changing this to be this. I'm not doing anything different. All right, these two equations are the same. I just simply took my 3x to the other side. So this is my new equation. And then I write my second equation. So this is my equation 2. So I have my two equations. I'm going to solve for x and y at the same time. So when we solve for x and y at the same time, the first thing you need to do, you substitute. You're going to say substitute. Substitute. To substitute, you are replacing. Substitute y is equals to 120 minus 3x. So what do I mean? Okay, into equation 3. You can't put it into equation 1 because this is equation 1. All right. So what do I mean by this? I am saying that wherever you see y in equation 2, please put 120 minus 3x. Wherever you see y in equation 2, put 120 minus 3x. Then you solve for x. Okay, let's do that. So my equation 2, so it means I'm going to have 2x plus 2. So my y, so this is y. So wherever I see y, I am going to put what? 120 minus 3x. And then this is equals to 100. So what did I do? I just replaced my y with 120 minus 3x. Where? Into equation 2. This is my equation 2. This is where y is. I put 120 minus 3x. Then I'm going to solve. This is going to be 2x. To break the bracket, we all know that we need to distribute. We did this somewhere in grade 9. Distribution, you say this times this, and then you say this times that. That's how you distribute. 2 times 120, I get 140. 2 times negative 3, I get 3x, I get negative 6x. Then this is equals to 100. And then now we solve like terms one side. You take 140 to that side. These two are like terms. They're not jumping an equal sign, so they stay the same. But the 140 is going to change the sign because it's jumping an equal sign. So it's going to be minus 140. And then now my answer is 2x minus 6x is 4x is equals to 100 minus, or it's negative, sorry. 100 minus 140, I am going to get a negative 40. I hope I'm not mistaken. Negative 140. Why am I saying 240? Why is it 140? It's 240. I said 240, but I did not write the 240. Please forgive me. Okay, so this is 240. And then this is going to be 140. Yes, 140. All right. Then now I need to solve for x. Okay, let me just rewrite this. Normally, this is what I do so that my students don't get lost. Then after this, I am going to divide both sides by -4 because I want to solve for x. I want x to be alone. So -4 and -4, they cancel. Then my x is equals to a positive 35. Positive 35. And let me confirm with my calculator. 140 divided by 4. All right, yes, it's 35. So now I have my 35. Then now, therefore, I'm going to solve for my y. With the point of intersection, you solve for both x and y, because it's simultaneous, solving for x and y at the same time. So I am going to use this one to solve for my, because y is already on my left-hand side. So I'm just going to say y is equals to, so this will be y is equals to 120, then minus 3. So wherever I see x now, what do? I put 35. This is how it works. Use x to find y, use y to find x. Then my answer is going to be 15. So what does it mean? So this means that So this means that my point x and y will be, for this point of intersection, will be when my x is 35 and then my y will be 15. So now we found our last point, which is 35 and 15. So we found it to be 35 and 15. All right. So these are the 4 points that we need. Feasible points, the corner point, sorry. Now we can solve. Now we can do that table of the corner point. So the table of corner point is going to be, I need that table to understand. Okay, so this will be my table for the corner point. Okay, and then, so this will be something like this. Okay, so it's gonna be this. Okay, I'm really trying here. Okay, we'll see. Okay, so I'm gonna start with the corner point. So the corner point, my corner points are from your visible region. Please don't forget that. Oh, sorry. Okay. Corner point is 0 and 0, 0 and 50, 40 and 0, and the new point that we found. So it's what? 0 and 0. So let's write that 0 and 0. And then we have 0 and 50. And then we have 40 and 0. And then lastly, we have this one, 35 and 15. Please don't forget the point of intersection. Please don't forget that. Oh, sorry. Please do not forget that. I know it's not easy to understand this, but please, I'm going to do another example. And then you're also going to have your tutorial, so it will make sense. All right. Now, and then we have calculations. Calculations. What are we going to calculate? We're going to calculate the profit. So I'm just going to show you to substitute, how to substitute. So it's 50x. Don't forget our profit function is 50x plus 30y. Please don't forget. And then this side, we have profit. Then we'll see the maximum profit. So this table is going to help us to get everything. Okay. Profit in rands. So we have, let me use the black one. So we have 50. And then we're going to substitute x. And then plus 30. Then we put y. And then we get the answer. So I'm just going to write these first so that I can just substitute. And then, yeah, so that it can be easier instead of writing the whole thing. Okay. Then lastly, okay. So I'm just going to substitute. So this is 0 and 0. X is 0, y is 0. X is 0, y is 50. X is 40. Y is 0. So I'm taking these from these points. Please don't forget, I'm taking this from the corner points. Okay. And then X is 35. And then Y is 15. And then now we get the answers. Okay, for the first one, obviously it's going to be 0. Obviously, if you don't have your X and Y, I mean, you're going to get a 0. Okay, there won't be production here. All right, then 50. So for this one, for 0 and 50, we are going to have 1,500. And then for 50 and 40, 50 and 0, so we're going to have 2,000, right? And then the point of intersection, we are going to have 2,200. All right. So you will see that when you compare this profit, the maximum profit is 2,200. So it means that for us to maximize the profit, we're gonna need 35 chairs and 15 sort of 35 tables and 15 chairs. Remember, X and Y are your tables and chairs. All right. So therefore, this means that the company will produce, excuse my handwriting, will produce 35 tables. How am I writing chairs? Gosh, 35 tables. 35 tables and 15 chairs. 15 chairs to maximize total profit of 2,200. I really hope this makes sense, but I'm going to do another example again. So I'm going to follow the very same steps. All right. Now let's look at, what is this? Example number 2. All right. Example number 2 says a bakery produces trays of muffins, trays of muffins, and trays of bread. All right, so already here we have our decision variable. I mean, by now you should know this is our X, this is our Y. So I just want you to see that this is just easy. All right, then they're saying that each tray of muffins uses 2 kg of flour and 1 hour of oven. Already you know on your table you're going to have flour and oven time. And then they're saying that each tray of bread uses 1 kg of flour and 2 hours of oven time. Oven time and flour, already you know the table. All right. Then the bakery has 100 kilograms of flour and 80 oven hours. You already know on your far right, you're going to have these two. I mean, now you know. Available per week, sorry. And then the profit is 300 per tray of muffins and 250 per tray of bread already. Anyway, let's see. Let me not say that. Maybe you don't get it. Right. Now let's start with decision variables. So decision variables, already we know that our X represents what? Tray of muffins. Trays of muffins. And then a Y represent what? Trays of bread. Trays of bread. All right. And then now we move on. They say write down the objective function and inequality constraints, including non-negative. Now you know we have to draw the table. We can't identify this, but okay, I can't. Maybe you can, but I can't. Okay. So I'm going to use the table like I did with the first one. So let's do that. So we already know our X and Y. I find it easy with the table. I hope you'll also find it easy with the table. All right. And then we have, okay, the price. Come on now. By now you should know we have the price. Okay, I know this is my X and Y. This is bread. Muffin, sorry. Muffin. Muffin, so this is X. Okay, muffins is X. Gosh, sorry, just need to make it space. Okay, so this is muffins. Muffins, which is X. And then we know bread, which is Y. Okay, and then now we know that here we have flour. Okay, I call it flour. I don't know how you pronounce it. Okay, and then we have oven time. Okay, and then we all know that this is the price. Gosh, this is, yeah. Okay, now let's write what we have. So we said that muffins, we have flour and then oven time. Okay, muffins, we said that we have 2 kg of flour and 1 hour of oven. 2 kg, 2 kilograms of flour and 1 hour of oven time. And then now we go to bread. Bread, we said we have 1 kg of flour, 2 hours of oven time. 1 kg of flour, 2 hours of oven time. Okay, now let's see. So they're saying that the profit, no, it's not that one over here. The bakery. So this is the bakery. The other one was the company. The bakery has 100. Okay. Bakery, or maybe I should write the bakery here. Bakery. Okay. And then this one, I'm going to say company. Maybe if we do this, it will be easy. Okay, this one was supposed to be company. Company. Okay, let's see. Company. Yeah. Okay. Hey, I hope it makes sense. Okay. Okay, company, bakery. Bakery, we have 100 flour and 80. So 100 kg flour, 100 kg flour, and then 80 oven time. Okay, 80 hours oven time. Okay. And then now we are going to do what we did on the first one. So we're going to start with the objective function. By now you should know objective function. Objective function. Objective function. What do we have? Oh, I didn't finish. Gosh, the price. The price is 300 per muffin. 300 rand, 250. Okay, I didn't finish. 300 rand. And then this is 250. Okay, sorry. 300 rand. And then this is 250 rand. Okay. Now we can go to objective function because this is basically our objective function. So objective function is profit is equals to P is equals to 300x plus 250y. Come on now. All right. And then now we go to constraints. Let's go to our constraint. Inequality constraints. Inequality constraints. Constraints. Constraints we are going to have so I didn't see them saying anything at most, at least. And yeah, didn't see that. So it's gonna be less than. Hopefully I'm doing the right thing here. Okay, so this will be 2x. Sorry. It's gonna be 2x plus 1y. It's less or equals to 100. I mean, we can have more than that too. I mean, to mix and make your muffins and bread. We all know that. Okay, and then we have 1x plus 2y. It's less or equals to 80. All right, and then now we have the non-negatives. We know that it must always be greater. That's what we said the last time. Okay, y is greater or equals to, because we can't have a negative, so it's a non-negative. These are your non-negative. All right. Yeah, those are the answers. Remember, I am using the table to get these. It's easier for me. I hope you also find it easy. And then now let's move on to C. So C, we have to graph it. I mean, we have to graph it. We're going to start with, let's start with this function first to look for the x and y intercepts. As I said before, we're going to look for the intercepts. Let me see what I wrote. I want consistency. Okay, intercept method. We're going to use the intercept method to plot the function. Just want consistency. Please don't mind me. Intercept method. We're going to use the intercept method to plot the graph. Intercept method. Intercept method. We start with the function first. So the function we're going to start with is 2x plus y. I'm going to just say y because 1y is just y, okay? Then it's equals to 100. So I'm going to start with this. And then we do the put y. Okay, so now let's start with put x. So we start with saying put x is equals to 0. And then you solve for y. Okay, so this will be 2. Wherever I see x, I put 0. So a bracket, then plus y, then it's equals to 100. So I'm going to put 0 here. So it means that I am going to have 0 times 2 is 0. So this will be y is equals to 100. So what does it mean? So this means that, or do I need to, yeah. So this means that x and y will be, when my x is 0, when I input 0, then my y will end up being 100. My y is 100, actually, not end up being. My y is 100. Okay. And then now we do the put y. Okay, we did the put x. Now let's go to put y. Put y is equals to 0. So wherever I see y, I'm going to put 0. So this is 2x plus. Then wherever I see y, I'm going to put the 0. So this will be 0. Then it means that 2, it's just going to be 2x is equals to 100. And then now I need to solve for the x. Remember, we divide both sides by 2. And then we cancel. And then our x is equals to 50. So what does it mean? It means that now my point xy is going to be, when my x is 50, then my y is 0. Okay, this is my second point. And then now we are going to use, sorry, I just need a space. Now we are going to use, okay, let me just, sorry. We're going to use the second function to solve this. Second function is 1x. So 1x is just x, right? So it's just gonna be, sorry, it's just gonna be x. It's going to be x plus 2y is equals to 80. Then I'm going to use this one and say put x, put y, same thing. Put x is equals to 0, and then we solve. If I do that, this will be 0 plus 2y is equals to 80. Wherever I see x, I put 0. Whether you use brackets or not here, it's okay. Then this will be 2y is equals to 80. So wherever I see y now, not wherever, I'm going to divide both sides by 2. Excuse me. And then these 2 and 2, they cancel. And then my y is equals to 40. So what does it mean? So this means that I am going to have my x, y will be, when my x is 0, and then my y is going to be 40. Input, output. And then now we do put y is equals to 0. Okay. So I'm going to put y is equals to 0. And then this will be x plus 2. So wherever I see y, I put 0. This is where y is next to 2. All right, 2 times 0, I mean, we all know that it's 0 now. So I'm just going to say x. Well, let me write it because, yeah, for now. Okay, let me write it. So this is just x plus 0. I mean, it's just... And then it means that my x is 80. Okay, then therefore it means that my xy will be, when my x is 80, sorry, not 40, 80. When my x is 80, oh, sorry, just need to correct this. Okay, so when my x is 80, then my y is 0. So this is my other point, sorry. Okay, so I have all my points. Where is it on top of this? Okay, so I have all my points. Okay, now let's plot the graph using the intercept. This is what we call the intercept method. I have my 4 points. 1, 2, 3, 4. Okay, so let's see. We're going to plot this graph using the intercept method. Okay, I hope I did everything right. Yes. So let's see. I'm going to use the intercept method. Don't know why this thing's moving. Okay. Just don't want to make a mistake. Okay. And then I just want it to be straight. Okay. Right. You don't really have to draw. I'm just doing this so that you can understand the feasible region. Okay. This is x. Like your questions are multiple for now. Anyway, it's multiple choice. Okay. So this is 0. So this is 20, 40, 60, 80, 100, 120, 20, 40, 60, 80, 100, 120, 120. Okay. All right. And then now we are going to plot. So I said that you plot one graph at a time. You plot for this function first. So 150. Y is 100. Go straight to 100. Please don't try to plot it with me at the same time. Just go straight to 100 and then put a dot there. Y is 50. Just go straight to 50 is between 40 and 60, right? And then just put a dot there. And then you take your ruler, you just underline. That's it. Don't try to make it difficult. And then now we move on to the second function. Second function is, okay, we have 40, y is 40, x is 80. Okay, y is 40. Okay, let me just use the red one. Y is 40, go to 40. And then x is 80, I go to 80. That's it. Then you just join the two. And then you're done. Don't try to confuse yourself. Okay, and then that's it. Then which one is the feasible region? This part. I mean, but now you know this is a feasible region. 1, 2, 3, 4, where you have your corner points. That's it done. Now let's shade. Let's try to look for a different color. Okay, let me use pink. All right, so I'm going to use my pink. Okay, let me start to use it here. Okay. Okay. Right. Okay. So as I said, this is the feasible region. Okay. This is the feasible region. Okay. And then I said this point is our point of intersection. Now we're going to look for this point. This is the point of intersection where you look for this point by solving things simultaneous. Point of intersection. By now, you know. Okay, maybe you don't know, but yeah. Point of intersection. And then this corner point is 0 and 40. This corner point is 0 and 0. This is our corner point. This corner point is what? 50 and 0. See? Then we look for this one. That's it. Now let's move. The question says, find the corner point and determine how many trays of muffins and trays of bread should be produced to maximize total profit. And I said that we need this point for us to determine the corner points, and yeah. So let's see. So we are going to do simultaneous again. So yeah, this is how I do it. So we're gonna say simultaneous. Point of intersection, we use simultaneous. I'm just gonna write it for consistency. I am going to say point of intersection. Okay, I want to, yeah, just want it here. Sorry. Point of intersection. Gosh, what's that? Sorry. Point of intersection. What do we the point of intersection? To solve for the point of intersection, we use simultaneous. We solve it simultaneously. Simultaneous. Don't worry, you're gonna get it. Do not worry. All right, so the first thing we all know, we have this. So I'm going to transform we have these two functions. The other function is 2x plus y. Okay, so we have 2x plus y. 2x plus y is equals to 100. By now, you know we need to transform this. Let's do that. By now, you know, come on. So it's going to be y is equals to 100. Then I take the 2x to the other side. Then it changes the sign, becomes a minus 2x. By now, you know. Right. So I'm going to call this my equation 1. This is equation 1. And then now we move on to the other one. The other equation is x plus 2y is equals to 80. So I'm going to call this equation 2. By now, you know, this is equation 2. All right. Then now I have my two equations, so I'm going to substitute. I'm going to say substitute. So substitute y is equals to 100 minus 2x. I'm saying replace y is equals to 100 minus 2x where? Into your equation 2. That's it. Into equation 2. I'm saying that wherever you see y, put 100 minus 2x way into equation 2 here. That's it. And then now we move. So I am going to have x plus 2. Wherever I see y, I use bracket. It's going to be bracket 100 minus 2x. That's it. And then now I distribute the 2. Equals to 80. Now I said distribute, say 2 times this, 2 times that. So I'm going to say x first. X, then it's going to be plus 2 times 100 is 200. 2 times negative 2x is negative 4x. That's it. And then this is equals to 100. Like terms one side. So this will be x minus 4x is equals to 80. Then I'm going to take the 200 to my right-hand side. It's going to be negative 200. And then now, x minus this, it's a negative 3x. And then this is a negative 120. All right, so let me rewrite this. Then now I need to solve for x. So I am going to divide both sides by negative 3 so that x can be alone. And then my x is equals to 120 divided, it's 40. So now I have my x, now I just get my y. Where do I get the y? I am going to use this equation, y is equals to, because it's easy. Then I just substitute, I replace x with 40. That's it, I'm going to use this one. I'm just going to say, therefore, it means that my y is equals to, since well, I have my x, I'm just going to say minus 2. Wherever I see x, I put 40. It's up to you. Even if you use the other formula, you'll get the answer. I'm using the easy one. Okay? Then my answer here is going to be 20. So what does it mean? Therefore, it means that my point of intersection, the point xy, will be my x is 40, and then my y is 20. So that's the point. This is the one. This one, point of intersection. That's where we get the 40 and 20. All right, so now I have all my 4 points. So now let's do the table. I know it's long, but it makes sense. If it doesn't make sense to you, you can find the other way of doing it. It's okay. Honestly, it's okay. All right. And then so I do it this way. I find it easy this way. And it makes things easy for me because I get all the answers that I need. All right. And this question, I think you'll have 1 or 2. It depends, but you'll see on your study guide what is it that they want. So I'm just teaching you everything, and then you'll see what is it that they want. Okay, so this is the corner point. Corner point. So the corner point, we always write it as xy. Corner points, ne? That's 8 points, okay? And then this is calculations. Calculations, we use the formula for profit, which is profit is equals to 300x plus 250y. Okay, and then we have our profit in rents. Okay, now we are going to have our points. We start with 0 and 0. All right, 0 and 0, then we say 0 and 40. They're from the graph, by the way. And then we have 50 and 0, and then we have 40 and 20. Now let's see. Okay, so I'm just going to write this first. You know how I roll because I just want to substitute. 300. I'm just doing this so that I can substitute. Honestly, you'll see that calculations column is not necessary. So I'm just doing it for you so that you can understand. All right. Okay. Just doing this so that it's easier. 50. Okay. All right, so now we substitute. So x is 0, y is 0. I take this from here, okay? X is 0, y is 40. Okay, this looks like a 6, 0. Okay, and then 50, 0, then 40, then 20. Okay, let's see the answers. For this one, obviously the profit is 0. If you don't have your, what is it, muffins and bread, you're not gonna, come on, you're not gonna make profit. Okay, and then let's see 0 and 40. Let's see the answer. We use our calculator, we're gonna get 10,000 rands. And then this one, we are going to get a 15,000 rand because 3 times 5 is 15. Come on now. And then this one, we are going to get a 17,000. So obviously you can already see the maximum. Okay. Remember, the aim of this is to maximize profit and minimize costs. Come on now. We're fine. All right. So now what does it mean? We are done. Therefore, it means that for the company, the bakery, to make profit, they need to produce 40 bread, 40 muffins, and 20 bread. I mean, now you're fine. Now you can answer this. I think that's it. So you need 40 to maximize profit. Come on now. Therefore, bakery should produce 40 the muffins and 20 bread, 40 trays of muffins. Gosh, it's trays, not just 40 trays, 40 trays of muffins and 20 trays of bread to maximize profit. I think, okay. Okay, yeah, I think that's it. All right. And then that is that. Thank you very much. I think that's it.